Today, we're going to be consolidating our individual entity sprite sheets into a big texture atlas. So we're going to be addressing this to-do today. Import shared assets only once and have entities refer to them somehow, for example, by index. Right now, when I load some, let's say 3 enemies, and these enemies are all of the exact same type, I end up loading the enemy asset path here. I end up loading the same asset over and over and over again. The texture is just going to be an asset tile set. The tile set has an atlas, and then it has some metadata about the atlas, the width in tiles, the width in pixels, etc. So I think in our game state, we'll just call it big atlas or something like that. I think in asset, we are going to place the compile time constants for the indices into big atlas. So right after we initialize the text, we will initialize the big atlas. We will be generating a tile map. We're going to throw the tile map itself away. This is basically just the only procedure that I have that will load assets from my binaries exported or converted from Sprite files. We can extend this to just work with tile sets, but it's not too costly to load in a tile map and throw it away. We just put it in temp storage and then clear the temp storage on the next frame. Asset load tile map, and that takes a renderer, which will be platform renderer, a pointer to the atlas tile map. We need the tile map path, so we're going to join the game state base path with data big atlas bind, and we're going to put that on the temp allocator. So now I actually need to create data big atlas bind. The way that we're going to do that is by making a new Sprite file here. I'm going to save in our game assets folder. Let's create a new folder called big atlas, and we're going to call it big atlas. Save. I'll bring in the text box tile set stuff. We can actually say layer convert to tile map. We'll come into the text box. I think we'll just control A everything and copy, paste. We now have tiles here. So player A sprite, it's going to be a 2x2. So if we come back here, we can grow the canvas size again by adding 32 to this to make 96. Use the guides to align that correctly. There's the ghost guy. Copy him, paste into big atlas. We have these unused tiles here. These will be in the tile map, but these will not be in the tile set. The tile set is the unique collection of graphics in the tiles here. So this will be the tile set. So this is kind of the idea of big atlas. We need to update the export tool. We don't need entities anymore. So actually we'll just change this to big atlas. Yeah, map will be distinct, but we don't need text and we don't need entities anymore. Let me remove some of the stuff from build data to force us to, well, let's see, we need to keep entities because we're not going to migrate the entities just yet. I will migrate text. So let's remove text. Oh, I have called it bit atlas. Text box tile map path. We don't need this guy, right? We get rid of all this. So we want to render text at. We no longer pass in the text box. We now pass in big atlas. Here are the indices into the text box texture atlas. We can now take in big atlas and we just have to update these in place. I will probably move these into asset as I mentioned, but we'll update these in place just to see if the rendering still works. Oh, I still have a text box tile set in here, render text box. So tile set with big atlas. We run and we render the text boxes. Create component names and types. So right now we have a tile set, but this is not going to be a tile set anymore. These are going to be like sprite indices or like atlas indices or something. So should we store indices here? Should we use a dynamic array? Should we do the trick where we have a specific backing storage and then we have a view over it? Because facing is an index into an atlas, maybe we don't even need to track this at all. At render time, we should be able to just look at the type ID and know that we need to go fetch a specific index from asset.jai to get at a specific tile in the texture atlas. So I'm thinking we actually just get rid of tile set entirely. All right, so basically everywhere we have a tile set, we need to get rid of this stuff. Initialize player, we get rid of the tile set here. This is entity load. We don't need to load a specific tile map for this guy, so we'll get rid of that. True if tile set loading succeeded, false if it failed for any reason. I think load itself just goes away. Let's get rid of load entirely. Hunt for more tile sets. Destroy an entity. Well, we don't need to destroy any atlases anymore. Render simple entity. Okay, so this is where we're going to switch on the entity type. Simple entity, maybe like render entity with facing direction or something like that. Maybe that's what I'll call it. So this is an entity view. We don't have a tile set anymore. This is actually a bit clunky because the source, as you can see here, is dealing with the tile set for the entity, and the destination stretches it over a map tile. Now, as I've noted in other streams, it just so happens that all of our tile sheets, or all of our tiles, have the same width and height across different kinds of components and map and whatnot in the game, so this works out. However, this is a bit of a logical inconsistency. I don't quite like this interdependence. I'll deal with that some other time. Initialize player. So TS, we no longer get a TS. Let's see, player asset path. We're not going to deal with that anymore. Player index is fine. So player asset path, don't need it. Tile set, don't need it. We don't load. Now the enemy asset path, don't need it. We'll get rid of this to do because we're addressing that right now. We don't need to entity load for the tile set. We don't need to pass in a tile set to initialize. So now that we've removed the distinctions or the discrete and the unique tile sets per entity, we are going to have to reintroduce, or rather we're going to have to compensate for that by adding some specialized logic. Let's have a supporting procedure that allows us to get Atlas tiles or entities based on the facing direction. When I pass in render here, we're going to need big Atlas. I guess we can just take in big Atlas here. It's going to be a non-pointer to an asset tile set, and we'll pass that along to render here. Get Atlas index. And we'll have an entity type, which is an entity type, and we'll have a facing direction. We need to return something. I guess it'd probably be a U64. We will now call get Atlas index. We're just going to map entity types and facing direction combinations to constants that will be defined in asset JI. Instead of doing EV tile set, we'll just have to do Atlas. Now here we need to support the player. Well, we need to support everything. So case player, case array, and also an unknown. Switch on the facing direction. And now we return specific values, and we'll encode those as constants. What is this? Get asset path. Oh, okay. That's cool. I had some utility here. I kind of stopped using it, I think. Okay, big Atlas index, player up. Player up is going to be 14, down is 13. We return this. We're switching on this guy here. And then we rinse and repeat this. We copy this and we paste this in here for the ghost. But the ghost is not going to have player. The ghost is going to have, let's see, array. It runs, and we are rendering, let's see, left, right, up, down, and the ghosts go left, and the ghosts go right, and the ghosts go down. Maybe instead of the entity type, we take the entity view. This way we have access to the backing entity data. So if the player has a special property, like if the case is a player, then we will check one of its other properties, like is invincible or something like this, right? And then we can use different indices to get the invincibility sprite. And that pretty much wraps up what I wanted to accomplish in this segment. So thanks so much for joining. Have a good rest of the day. We'll see you next time. Peace.